Friedrich Wilhelm Bessel. He was born in 1784, and in the year 1838 he calculated how far a star is away from the Sun, 61 Cygni. And he did it using the Parallax Method. Now it works like that. Basically how it works now in small, if you hold your thumb out close to the eye and you look now with one eye and the other eye, when you see the thumb in front of a 4 or 5 meter away background jumping a meter. If you hold your thumb completely out with your arm and you switch and look always with one eye, you can see it switching just around 10 centimeters apart. So the further the object is away from which you change the angle of looking at it with the eyes, the less it jumps. So I have it very close and the angle changes now dramatically and you see completely different background basically. If you have it far away, it jumps just a little bit from side to side. Now the Earth is rotating around the Sun once a year. So 6 months later, the Earth is on the other side. So if the people on the Earth looking to a star, by seeing it in that angle, 6 months later they've changed the angle, just if looking with the eyes on the other side. The Earth is changing. And if one now looks, the background switches as well. If a star is very close to the Earth, and the people looking from here to the Earth, they see that background. And 6 months later, we're looking from here and we see that background. So very far away. If a star is very far away and we look, we see just a tiny bit of switch in the background. It jumps just a little bit. And basically with these things it can be calculated, and that switch is called the parallax. With that difference it can be calculated, is the star pretty close, because there's a big switch in the background, or very far away, because there's just a very little switch in the background. It works until 100 light years away. When the CFA variable is used, CFA variable, these are stars which are getting brighter and not so bright, always in fixed periods. And the longer the period takes, the brighter the star is. If it takes 1 day, it is not so bright. If it takes 10 days to go full brightness and lowest brightness, it is a very bright star. And with now measuring around knowing how big how big that brightness is by knowing it is 10 days and not 1 day, with comparing it to how bright it appears on Earth, it can be calculated how far it is away. So see the variables. It goes brighter and not so bright, so it is able to measure how bright is it actually. If it takes 10 days, it is very bright, 20 days even more brighter, 30 days even more brighter, 2 days not so bright. And when it's looked how bright it appears it on Earth, the stars don't appear so bright on Earth, because they're very far away. Comparing these two measurements, knowing how bright is it actually, because the longer it takes to get bright, not so bright, it can be seen on Earth, it is known how bright it is. Comparing it with how bright it appears on Earth, and we now know for stars which are more than 100 light years away. But for less than 100 light years, this method works with looking with the angle, very close, big switch, very far away, small switch. And that can be calculated and heated. And that is according to the Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of the Universe, written by Ian Ridpath and John R. Shakespeare, on the page 50.